Hello guys, welcome to Fire Racer Workshop, and in today's video we're gonna be simulating another experiment on TinkerCAD, not on OrCAD, TinkerCAD. Now the aim for the experiment is to simulate the center tapped rectifier. Okay, so we're gonna be simulating it on TinkerCAD. Now the circuit of this particular experiment is a bit complicated, to be honest, for a first year student, because it just uses some op amps that are needed to just create 180-degree out of phase sine waves. So this is there is no other way to simulate this experiment on this particular TinkerCAD software. So on TinkerCAD this experiment cannot be performed if we don't use this kind of circuit. So I'm just going to show you how to use this kind of circuit, and I'm just going to also give you a brief about the op amps. The full form of op amps is operational amplifiers. You can also click on the pop-up I button to watch Dave's video on this particular topic. So he has just explained op amps in real great depth, and you'll just love that video. Seriously, that video is just really good for basics. I'm just gonna link it on the pop-up I button. So anyways, so let's just get started. So over here I'm just gonna simulate this circuit. You can see we're just getting the proper result for the center tap rectifier. And over here these two op amps are just one of them is in the inverting configuration and one of them is in the non-inverting configuration. This one is in non-inverting and this one is in inverting configuration. This is powered by a split power supply, and here's a function generator that's set to 60 Hz and 10 volts peak to peak. So we're just gonna alter the circuit a bit because we want a particular gain on the amplifier. So I'm just gonna show you how to simulate the circuit. Alright, so let's just stop the simulation and let's just fire up TinkerCAD. Now I've already performed many experiments. I've already performed all the second semester BTECh experiments for electronic devices have been covered on my channel on OrCAD software. The TinkerCAD has I'm yet to cover all the experiments on TinkerCAD, but I'll just soon cover them as well on TinkerCAD. So you can just click on the pop-up I button to view the full playlist for the experiments that I performed on OrCAD. So these includes all the experiments that you have to perform in the BTECh second semester in electronic device. Okay, so with that said, let's get started with the circuit. First of all, what you need is a breadboard. So breadboard is the major component in this particular circuit. So let's just import one breadboard. Alright, now you need two power supplies. Now we're just gonna create a split power supply. Okay, so in the instruments you're just gonna drag two power supplies because we need two of these power supplies to create a split power supply. Let's just also import a function generator. Okay, so here's the function generator, and let's just import our op amps, or operational amplifiers as we like to call them. Actually, we don't like to call them operational amplifiers, so I guess we have to just search for the ICs. So let's just go to the ICs tab, which would be better instead of just searching. Over here you can see integrated circuits. Now you will just find operational amplifier over here. You can see this is a 741 operational amplifier. Now the datasheet for this particular op amp I'll be linking in the description down below, so you can have a look. You can also see the slew rate, the gain bandwidth product, the DC offset, and the rail to rail the split power supply range, the maximum split power supply range for this particular op amp. So but I'm not just gonna bother myself with all that stuff because I'm just gonna simulate a normal circuit at 60 Hz. So I just don't need to care about the gain bandwidth product and the slew rate. So these are the two major components that just influence the performance of an op amp in the amplification. So we also need resistors, and we need 4 resistors for the op amp to create the op amp configurations, the inverting non-inverting configurations. Okay, 2 for each stage, and we need 1 resistor for load. We also need 2 diodes. Let's just drag and drop them at once only. Okay, so it's just easier for us to place. Now what I'm planning to do is I'm just gonna create a 2x gain on the op amps, and I'm just gonna set the power supply to 5 volts. Alright, so it will be 5 volts peak to peak. So I'm just gonna set it to 10x, 2x gain. So it will give me an effective value of 10 volts peak to peak. So 2x gain means it's just gonna multiply your amplitude by 2. So you can just understand the gain by this only. So okay, so let's just wire up our circuit. First of all, I'm just gonna wire up the power supplies. So this is a split power supply that we'll be creating with using these two lab bench power supplies. Okay, so let's just square things up a bit. So this is gonna act as our ground. So this thing will be shorted to the negative terminal of our function generator. So let's just connect our function generator as well to one of the negative rails of our breadboard. Okay, so please be neat in this particular circuit, otherwise your circuit is just gonna look messy and it ain't gonna look good. Okay, you're just gonna get yourself like really confused after preparing this circuit, because seriously, for this particular circuit you need to have neatness in your circuit, otherwise it will just become confusing for you. I've been working with op amps like for around 3 years now, so I just don't have such kind of problem that I'll be like not able to figure out the circuit. Now let's just wire up. So first of all, we are just gonna connect our ground to right here. So let me just connect my ground. Okay, right here it will be connected to the ground, so this will act as a reference 0 volts. So we are just gonna assume it to be 0 volts. However, this is not 0 volts, but still we'll just assume it because we are just considering our power supply to be split power supply. I'm just gonna short these two rails. So this is the negative rail, and this will be like shorted to this rail right here. So this is the common 0 volt rail, and this point right here will act as a negative voltage rail, and this one will be a positive voltage rail. So anyways, I'm just gonna color code these wires as black right here. I'm just gonna color code it as black as well. So over here you can see you have to provide the power to your op amp ICs. So this is the power minus. So from here we'll just draw a wire to this negative terminal. So this is the negative power supply that we have to give to our op amp. Similarly, for this particular op amp, we are just gonna hook up the power minus to right here, to where this power to this pin right here. Okay, so over here we have just hooked this up to right here, and let me just make it a bit neater for you to understand. Let me go back and let's just hook it up from right here. All right, and we'll just go to there. Now we're just gonna hook up the positive power supply rail. So let's just do it. And so this is the power plus for our op amp. This is the pin number 6. So let's just hook it up, square the wires a bit, because again you have to keep your circuit really neat, otherwise you're just gonna get confused. I've been working with op amps for almost 3 years now, so I won't just get confused, but I want to like show you guys like how this thing works. So I'm just gonna keep my circuit as neat as possible. So I'm just gonna take a lot of time with this particular experiment. So your op amps have been wired for power. So what we are gonna do is, now we're just gonna place the resistors. So on your screen right now you can see the diagrams for the op amps, and one of the diagram on the left hand side is the op amp in a non-inverting configuration, and on the right hand side is an op amp in inverting configuration. So this particular op amp I have selected to be in the non-inverting configuration, and this particular op amp will be in the inverting configuration. So we're gonna hook up these things according to the schematic diagram as shown on your screen right now. So over here you can see there are several pins that are included in this IC. So in negative is the inverting input of the op amp, in plus is the non-inverting input of the op amp, and over here this is the out terminal. So this is the output of the output of the op amp. So we're just gonna draw our output from here, and this is gonna act like the in minus will be directly so we are just gonna connect one resistor right here. So I'm just gonna drag and drop this resistor. I'm just gonna also rotate it. Just press the R key to rotate your resistors. So I'm just gonna place it right here. Okay, and I'm just gonna take another resistor. I'm also gonna rotate it, and I'm just gonna place it right here. So I'm just going according to the schematic diagram and the circuit diagram. So I'm just gonna place a wire. So this is the out. Alright, so I'm just gonna place a wire right here. Okay, so this is how this has been like somewhat complete. Now we're just gonna hook it up to the negative terminal. Alright, let's just color code it as black. This circuit is just gonna take a bit more time to simulate, so please bear with me. If the video is gonna be long, then please just watch the video till the end. Otherwise you'll just get confused if you just like try to copy my circuit without even knowing what am I showing in this video. Alright, so your circuit has been wired up. We are just gonna change the resistor values a bit later, because I also have to explain you how to set the gain of the op amp correct. So let me just wire up the second op amp as well. So second op amp will be wired in a in an inverting configuration. So this is just gonna generate the 180-degree out of phase wave, and then I'll explain how it works. Alright, So I'm just gonna rotate this resistor as well. So over here this is the in minus. Okay, so over here to the in minus we'll be connecting this resistor. Sorry, I don't know why am I just dragging this. To the in minus we'll be connecting this resistor. Okay, so this resistor will be connected directly to the input. I'm sorry, yeah, the input, that is just like the output that's coming from the function generator. So this is just going to be connected directly to there. I'm just going to color code it as green, and I'm also gonna connect the positive, like the in plus. So this terminal right here will also be connected to the function generator's output. So I'm just gonna also connect this one as well. Alright, so this one will also be color coded as green. So this op amp is all set and ready to go. So this op amp has some work left to do, so I'm just gonna hook up another resistor to this particular op amp, and I'm just gonna place the resistor right here because this is just gonna go to the output of the op amp again. So I'm just gonna route it to the output of the op amp. Over here this is the out, and I'm sorry, so right here I've just placed it at the output of the op amp, and I guess this is alright. So I'm just gonna color code it as yellow, right? So this has been set. So this operational amplifier has also been set. So this operational amplifier has also been set. There's one more thing that we need to do. You have to connect the in plus to the ground. Alright, so we have to connect the in plus to ground. So that's the last thing that we had to do. So I'm just gonna color code it as black because this just like directly shot it to the ground. So over here now what we'll receive is from the output, this is just gonna give us the normal this, like for example if you're like on your screen, like you can just see a transformer right there. So the top terminal will be like this op amp right here will act as a top terminal for the transformer, the center tap transformer, and this one will act as a bottom terminal of the center tap transformer. And this rail right here, these negative rails will act as a center tap for the center tap transformer. So this is how our circuit will be, like this is how we'll be simulating a circuit. So let's just add a diodes as well to the circuit. I'm just gonna add the diodes. So I'm just gonna go with this orientation right here. You can go with any orientation, but just keep both the diodes in the same orientation. Alright, so I'm just gonna keep both the diodes in the same orientation. And right here is the output of the op amp. So I'm just gonna connect one diode to this output and the other diode to this one. Alright, so I guess I just need to tidy things a bit. So let me just make this a bit more tidy. Alright, there you go. Now you can just easily distinguish which wire is which. Alright, I just don't want to rush this circuit development, otherwise you people are just gonna get confused. So I'm just gonna color code it as this color. I don't know whichever, like whatever color this is. So anyway, so this is for the outputs that we are getting. So both these are the outputs for the secondary for the you can just assume it to be a transformer right now. So this is the secondary winding. So these are the two outputs that we are gonna get from the secondary winding, and this is gonna be the center tap. So we're just gonna connect the output of these two diodes together using this wire, and accordingly we'll just get our negative terminal right here. Alright, so this is just gonna act as a negative terminal. So I'm just gonna color code it as black. Alright, just gonna color code it as black. So this resistor right here, okay, so I'm just gonna rotate this resistor. So this is all set, and this center tap, so after this, like this center tap is just gonna act as a positive. So let me just place it right here. Alright, or we can just do one thing, we can also just change the orientation of the diode. So this is in the correct order, so let me just change the orientation, so otherwise you people are just gonna get confused. So I'm just gonna change the orientation of this diode. So now this will act as a positive. So I'm just gonna color code it as red, and this one I'll just color code it as black. So we're all set on this particular experiment, and now just like change the values of the resistors. So let's just give the correct value for the resistor. Now for the inverting configuration, okay, for the inverting configuration of an op amp, so this particular op amp is in the inverting configuration and this is in the non-inverting configuration. For the inverting configuration, the formula for gain is, if you consider this to be RA and this to be RB, sorry, this to be RB and this to be RA, so your gain is gonna be equal to RB by RA, so RB divided by RA. So we are just gonna keep the value, so we want a gain of 2, so let's just keep it at 3. So okay, so we're just gonna keep the gain at 3. Okay, so let's just keep it at 3 kilo ohms and this one as 1 kilo ohm. So this is all set. For the non-inverting op amp, the gain is gonna be, if you consider this to be your RB and this to be your RA, so it is 1 plus RB by RA. So this is gonna be a gain, so I'm just gonna set it to 2 kilo ohm and this has 1 kilo ohm. Okay, I'm sorry, I don't know how I just picked up a wire. Anyway, so this is at 1 kilo ohm and this is at 2 kilo ohm. So essentially it's just gonna give us a gain value of 3 on both the amplifiers. So for example, this is at 1, this is at 2, so this is 1 plus 1 by 1 plus 2 by 1. Okay, so this is how the gain will be decided for this particular op amp. So this will become 3 and this is already at 3 because this is at 3 kilo ohms and this is at 1 kilo ohm. So our gain is all set. Let us set our power supplies as well. I'm just gonna go with a voltage of 17 volts. Okay, 17 volts for both the power supplies and the current limit of 5 amps. That's okay. So according to the data sheet of the op amp as well, so this is the data sheet for the UA741 op amp. So according to the data sheet over here, you can see this is the maximum rated, where the hell is it? Okay, so this is the maximum voltage that we can supply at the rails. So this is plus minus 21 volts. So this is the VCC, the supply voltage. So plus minus indicate that, okay, so this is the split power supply rating for the op amp. So anyways, what the fuck is it? Let's just set a function generator as well. I'm just gonna set it to 60 hertz, amplitude of, so it's at 3x gain. So let's just set the amplitude to be 5. This is just gonna essentially give us 15, but I guess we should like keep it on the safer side, so let's just set it at 4. Alright, so 4 3 is 12, so this is just gonna get us an output of 12 volts. So we are well within the range of the power supply, because you just don't need to exceed this value, and you also have to just keep a margin of around 1 volt. So because these op amps are not rail to rail, otherwise you're just gonna, your output is just gonna look a bit cut off. So we just don't want that. Anyway, so let's just also make the offset at 0.00 and set it as sine. Alright, so your circuit is just ready to be simulated. Let's just add an oscilloscope, I mean 2 oscilloscope. Alright, this is the oscilloscope. First of all, I'm just gonna probe the input for this particular circuit. Alright, so I'm just gonna show you how the input for this particular circuit looks like. So right here, I'm just gonna probe it for one of those, and for the, I'm also gonna import another oscilloscope as well. So let me just probe the second output as well. Alright, you won't be able to see the correct like phase difference and all that stuff like in this particular simulation, but because these oscilloscopes are like independent of one another, so the triggers ain't set like in synchronization. So for example, like both of these will just show a sine wave. Let's just set the time division to 4 millisecond. Similar case over here, 4 millisecond. You can go as to at 3 millisecond as well, but let's just keep it at 4 millisecond for now. So I guess this is all set up, and let's just hit start simulation. Over here you can see we have just got ourselves our sine wave that we required, and over here you can see the voltage that we are getting. So this is 20 volts in total. So there are 1 2 3 4 5 6 7 8 9 10 divisions in total. So this is 2 volts per division, 1 2 and 3. So 3 means 6, so this is 6. So this is almost, so see, you can see the peak to peak voltage is around 12 volts. So these are 3 divisions, so 12 volts peak to peak at both the op amps, because we just set them to 2x gain, and the supply that we have selected, we have just set it to 3x gain, and the supply that we have selected is 4 volts. So we are just getting the correct values, but to show you that, okay, so these are 180-degree out of phase. Okay, so if I just probe, so these are just like, these oscilloscopes can take the floating measurements. So I'm just gonna stop the simulation for now. So over here you can see the voltage that you got is around 12 volts. So these oscilloscopes take floating measurements. So let's just wire one of the oscilloscope instead of to ground to the other terminal. So this is what it's essentially going to do is it's just going to measure between those terminals. So essentially what you would have got in a center tap transformer is that your voltage is going to double, because this is like 180-degree out of phase, so your voltage is going to be twice that you were getting with the center tap. So let's just simulate the circuit now. Over here you can see, again you can see this has just changed to 40 volts, and this is like 4 volts per division. So you're getting around 24 volts peak to peak voltage now. So this circuit is just like working like a charm. So we are all set over here. I'm just gonna reset the oscilloscopes so that you can just like view the circuit a bit better. I'm just gonna stop the simulation, delete this oscilloscope, add another oscilloscope. Alright, we're just gonna go with 2 oscilloscopes right now. Short this to the ground. For this oscilloscope as well, we're just gonna connect it to the ground. Alright, so the positive terminal is gonna be connected to this particular breadboard rail. So this will just act as a positive rail. Okay, and for this, the positive rail is just gonna connect to the input of one of the diodes. So I'm just gonna connect it right here. Alright, again I'm just like squaring things up a bit because it just like looks a bit neater if you do so. Alright, I'm just gonna color code the wires as red as well. This one as well, I'm just gonna color code it as red. So now let's just simulate a circuit. I'm sorry, I just forgot to change the time division. So the time division should be 4 millisecond. For this oscilloscope as well, we're just gonna go with 4 millisecond. And if you're asking yourself how I got this value of 4 millisecond, just open your calculator. 1 divided by 60, and 1 divided by 60, so 60 hertz is your frequency. So we just want the time period for our wave. So this is 16 milliseconds. So for 16 milliseconds, so this is just going to be the time period for your wave. So what this 4 millisecond means is that the time division of your oscilloscope is 4 milliseconds. So this is the time division. So over here on the x-axis you can see this one division will be equal to 4 millisecond. So thereby, so 4 millisecond will be like more than enough to just view our wave. Okay, so this is how I just got the value. Anyways, let's just start the simulation now. Now you can see the beautiful graph for this particular experiment. So this is the expected graph. You can see over here, right here, we are just getting the like a beautiful sine wave, and over here we can see the rectified sine wave. So all the negative bumps, like these are actually the negative bumps are just blocked in both of these cases. So one of the waves is this 180-degree out of phase, so is just having positive bumps. Like for example, if this is at positive cycle, so this one will be at negative cycle. Okay, so this is just gonna let the electricity flow, therefore you just get one bump over here. Like I'm just gonna call it a bump, so you can just call it a wave. Okay, so you just get a one positive bump. So when this one will be at negative, so this one will be at positive. Again, it's because it's just 180-degree out of phase, so again this diode will start conducting and you will just get another positive bump. So this is how the circuit works, and our circuit has been like completely simulated. In the previous circuit that I showed you, I had just put the op amps as a buffer. So this one will act as a buffer and this one will act as an inverting op amp at 1x gain. But I just like double the gain a bit so that it's just much more easier for you to understand, because I'm just not gonna go into buffers and all that stuff. So you can just understand it like this. So this one is in the inverting configuration. So this op amp is in inverting. So this is it at non-inverting, and you can just watch that Dave's video from EEV vlog. So he has just made an awesome video about this topic, so you can just watch that video if you're just like beginning with electronics and all that stuff. So that's all for this video, guys. I hope you enjoyed my video. So make sure to hit that like button and do subscribe to my channel and share this video with your friends as well. So see you in the next video. Bye bye.